Here's integrated 3. It's problem 12-50. It says Ingrid is standing at the Schoolyard Express chairlift, which is 412 feet from the base of the Broadway chairlift and 348 feet from the entrance to the lodge. The angle made by looking at the Broadway chairlift and the lodge is 39 degrees. How far is the base of the Broadway chairlift from the lodge? So that one it's just too much, too abstract to be able to try to think about it without drawing a picture. I suspect the picture is going to be a triangle because it's giving me 2 side lengths and an angle. So I'm just right off the bat going to just draw. I already filled this in, but I just drew. I didn't even care what the angle measures are. I just drew myself just a generic triangle. I know that's more than 39 degrees, but I drew myself a triangle, and I said, okay, let's go back to the question. It says, she's standing at the Schoolyard Express chairlift, so I just said S for schoolyard. And then it's 412 feet from the base of the Broadway chairlift, so I know one of these other 2 has to be Broadway. I just let it be this one. And I labeled it with the 412. And then it's talking about where she's standing right here at the schoolyard. And it says that she's 348 feet away from the entrance of the lodge. So it's got to be this, because this is where she is right here. So it's got to be that side. That's the 348. That's L for lodge and B for Broadway. And then it says the angle made by looking, remember she's standing right here, the angle made by looking at the Broadway chairlift and the lodge, like here and here, is 39. So hopefully that's where we put the 39. That's what makes sense to me. And then it says how far is the base of the Broadway chairlift from the lodge? So I just called it X. And then I was just going to do law of sines on it because it's a triangle problem, but I don't have a pair, like I don't have enough angle measures to do that. So I knew I had to use law of cosines. So you can just Google law of cosines and get this, or you can memorize it, or you can write it on your cheat sheet. But this is a formula called law of cosines. And I don't bother naming my sides A, B, and C. I just know that the one that has the angle measure, like see how the A's and B's, they don't have anything to do. This is the angle measure. So I need to make sure that I use C when I'm talking about this vertex right here. And if cosine of C is this vertex, then side C is going to be this. So in other words, I'm going to put my X in for C, and I'm going to put my 39 in for cosine C. And then the other 2 values, it doesn't matter which one's A and which one's B, because I'm just squaring and adding and multiplying, and those are all commutative. So it doesn't matter which order I put them in or anything. So the important thing is that I used this one and this one in these 2 spots, and then fill in the rest of it. So this is just me filling in law of cosines. And I'm going to be brave. Normally I show you the order of operations because people always make a mistake. They try to find out what these are, and then they go ahead and subtract this number, but you can't because of the order of operations. And I always say, well, just you can type it in your calculator. I'm going to try. So I typed it in. I just typed it in exactly how it looked. So I wrote 348 squared plus 412 squared minus 2 times 348. Oh, I put myself in degree mode. Times 412 cosine 39. And I'm in degree mode. Uh-oh. Okay, so now I'm going to push equals and see what happens. Now that's a big number, but I know that that's x squared. So I hope this is going to be right. 67999.84. So x would be the square root of that. So I'm going to push square root, answer. Hey, we got it. So this is about 261 feet. Okay, I hope that made sense.